So we're going to talk about complex numbers. Does anyone remember from, a little while ago what complex numbers are? They're numbers with our favorite letter, I. So complex numbers include the letter I. Do you remember what I represents? It is equal to the square root of -1, right? So if we had the square root of -3, we would call that I radical 3. Yes? Now, we are not going to be working with the square root so much as specifically just dealing with these I numbers. So the first question I have is, what is standard form for a complex number? Because your homework, it says simplify. Make sure your answer is written in standard form. So standard form for a complex number is A plus BI, meaning that the last thing written has to be your I. Capiche? So there's a few different ways of writing complex numbers. You could have something just 2I, meaning there is no A part, it's just the BI. You could have something like a negative. You could have an I in a fraction. If an I is in a fraction, you can actually put it on the numerator, or you can put it out to the side. Either way is acceptable for standard form. Okay? When we have a radical, we tend to put the I in front. Why do we do that? Clarity. Because if I did this, there's a little bit of fuzziness as to whether the I is underneath the radical or not. So just to make it clear, we put it in front. So the only time that I is not at the very end of the problem is when there's a radical. All right? And then this is kind of a combination of part C and D. If you have a fraction, you can either put it on top with the radical or out to the side after. I prefer out to the side after and just always going in this A plus BI, keeping it all simple. Okay? So, when we have A plus BI, there are two parts to the number. There is a real part, and there is an imaginary part. The real part is the A part. The imaginary is the BI part. So if I gave you the number 9 plus 5i, do you see how it's in A plus BI form? What would the real part of it be?
9.
It would be my A value, which is 9. What would the imaginary part of it be?
5.
Positive 5i. What about in letter B? What would the real part of this one be? This is a little bit of a trick question. There isn't one, is there? What does that mean?
0.
It's 0, because couldn't I write this as 0 minus 7i? So the real part is 0. The imaginary part is what? Negative 7i. So? What about this one? The real part is what? 11. The imaginary part would be what? Now, I have to be careful how I write that. I'm going to write 0i because the imaginary part always has to have the I with it. Make sense? And then the last one, what's the real part? -1, and the imaginary part, I. So, what we're going to be doing this week, and you're going to have a quiz on it on Friday, is we're going to be taking these imaginary numbers, or these complex numbers, such as 9 plus 5i. We are going to add them, subtract them, multiply them, and divide them. That's what we're doing this week. Today we're focusing on what? Adding and subtracting. Adding and subtracting is super, super easy. If you look down at number 3 and on, what do those problems look like? No. They should look like stuff we just did in like the first week of the semester, where we're just going to get rid of parentheses and then combine like terms. Right? That's all we're going to do for adding. Adding and subtracting. You just get rid of your parentheses, combine like terms, and make sure your answer is in this standard form. All right? So let's look at number 3. How do I get rid of parentheses if there's nothing to distribute out in front?
1.
You put a 1 there. If there's nothing to distribute, you assume it's a 1. What's 1 times negative 5i? And what's 1 times negative 6? And 1 times negative 5i? All right. So what like terms do I have? And negative 5i. What's negative 5i and negative 5i? Negative 10i. And then I have a minus 6. Do I put minus 6 like this?
No.
Why not? Because that's not in standard form, is it? So I'm going to put the minus 6 in front instead, because now I have it in the a plus bi form. That's as difficult as it is today. All right, let's look at number 4. How do I get rid of the parentheses? Put the 1s in front. What's 1 times negative I? Negative I. And negative 1 times 2i? Negative 2i. So what's negative I and negative 2i? Negative 3i. Is that standard form?
Yeah.
Yep. Now, if I asked you about standard form, what's A? 0. And B is, or the imaginary part is negative 3i. B is actually just the negative 3. All right, so let's go to this guy. Again, throw those 1s in front of the parentheses. What's 1 times 7i? And then I got to distribute here. 1 times negative 7 is negative 7. 1 times 4i is positive 4i. And negative 1 times 7i is negative 7i. Where are my like terms? 7i, 4i, and negative 7i. What do you notice there? Those two are going to cancel, aren't they?
Yeah.
So what I'm left with in the middle is actually just my answer, because that's already in standard form, isn't it?
Yeah.
Beautiful. So when I'm adding and subtracting, is there really any difference between an I and, say, an X? Is there any difference in how I treat it? The only difference comes with making sure that the I is at the end when you combine your like terms. Okay? All right, let's try number 6. What do I do first?
Put a 1 in front of the parentheses.
Put a 1 in front of the parentheses. Does anything happen to the negative 8?
No.
What about the negative 3?
No.
Positive 1 times positive 1 is positive 1. Positive 1 times negative 4i is negative 4i. So let's see. Negative 8, negative 3, and positive 1. What does that get me? Negative 10. Again, think about it like money. You owe $8, then you owe another $3. That means you owe 11 total, right? But then you get $1. So if you pay that $1, you're still owe 10. That's your balance right there. And then I have minus 4i. Is that in standard form?
Yeah.
Yes or no?
Yeah.
Yep. All right, you take a minute and work through the last 4. All right, I'm going to start slowly working on number 7 here. Putting 1s in front of my parentheses. 1 times negative 3 is negative 3. 1 times 3i is 3i. 1 times negative 5 is negative 5. 1 times 7i is 7i. And then I have a minus 5. Which terms do I want to collect first, or which ones do I want to put together? I'm going to do the numbers first, so that I keep it in a plus bi form. Negative 3 and negative 5 is negative 8, and another negative 5 is negative 13. Done with those guys. Now I have positive 3i, and positive 7i would be positive 10i, and that's my answer for number 7. Raise your hand if you got that.
I got it.
Good job.
I got it.
All right, number 8. Do you see how I'm trying to make it like oh so much more complicated by giving you like 3 sets of parentheses? Yeah. because there's not much you can do to make these more difficult. There's my 1. All right, 1 times 3 is 3. 1 times 4i is 4i. 1 times 7 is 7. 1 times negative 2i is negative 2i. Negative 1, do you notice when it's a subtraction I have to distribute a negative 1? Mm-hmm. Yeah. Negative 1 times negative 4 is positive 4. Negative 1 times positive 4i would be negative 4i. So looking at just my numbers, 3 plus 7 is 10, plus 4 is 14. All right, done with those guys. 4i minus 2i minus 4i. I notice those two cancel, so I just have minus 2i. Woohoo! All right, down here. 1 times 1 is 1. 1 times 5i is 5i. 1 times 3 is 3. 1 times 2i is 2i. Negative 1 times negative 8 is positive 8. And negative 1 times negative 2i is positive 2i. So let's see. 1 plus 3 is 4, plus 8 is 12. Done with those guys. 5i plus 2i plus 2i, what does that give me total? 9i. So, even though I've said it a million times and all of the problems are done the exact same way, I'm still going to get people that will ask me, will you still give me credit for this?
No.
And what's my answer going to be?
No.
Apparently you guys don't know me very well. You will definitely lose points for that, because the very first thing we did on here was talk about how your answer needs to be written. And every single answer that I've written has been in that form. Okay? So don't be lazy. Figure out the standard form part. The rest of it is easy. It should not be hard. All right, last one. Putting my 1s in there. 1 times negative 5 is negative 5. 1 times 7i is 7i. 1 times 3i is 3i. Negative 1 times positive 1 is negative 1. And negative 1 times negative 6i would be positive 6i. So let's see, if I combine my like terms, I have negative 5 and negative 1. What does that give me? Negative 6. And then 7i plus 3i is what? 10i. Plus 6i is 16i. Easy peasy?
Let me squeeze it.
Awesome. Happy studying.